Good. So I think we can start. So a very warm welcome to our second edition of our workshop on unsupervised learning for automated driving. This workshop is happening now the second time in the IEEE IB Symposium. Myself, Fabian Flohr, and Julian Kooij, we are the workshop chairs, and I want to actually start with a quick introduction of the both of us, where we are coming from. So Julian Kooij is assistant professor in the Intelligent Vehicles group at the Technical University of Delft in the Netherlands. He's mainly taking care about, with his PhD students on the whole vehicle perception and machine learning topics here. He worked with me also on multiple vulnerable road user topics for perception and understanding and path planning, path prediction. So I'm with Mercedes-Benz AG at Germany. So I'm function owner for the vulnerable road user protection topics, level 4, level 5 automated driving. Quick note, this workshop is supported by the IEEE ITS, the Technical Committee for Self-Driving Automobiles. So let me start with a quick motivation why we are actually doing this workshop. Actually, in the intelligent vehicle domain, we are quite lucky because we have a lot of great data sets. We have, for example, the Kitty Vision benchmark suite, which is coming with a lot of different benchmarks, actually, from stereo estimation over object detection to object tracking, behavior analysis, and so on. We have the Cityscapes dataset, which is focusing on image segmentation. Recently, there have been a benchmark on 3D box estimation being appeared. The Eurocity persons dataset is focusing on the whole vulnerable road user protection topics, detection at forehand, but there will be soon also a tracking dataset. The new scenes, which is the same as the Kitty benchmark suite, coming with a lot of multi-model representations and a lot of benchmarks, a lot of tasks. So this is actually quite a nice setup for us as researchers. So we can experiment a lot with this dataset, and we can clearly find out in most of the cases which of the algorithms are the best, right? The question is now, for automated driving, are those datasets, although they are recorded in a quite extensive manner and in a quite large diversity, for example, the Cityscapes dataset have been recorded in whole of Germany, the Eurocity persons dataset in whole of Europe. So, but the question is that already enough for, let's say, level 4, level 5 automated driving? Is the data complete? And the answer to that certainly is and will be forever, or nearly forever, no, this is not complete. And the question is, how high can we get actually to make them complete? And can we go up to, let's say, 90%? Can we reach 99%? Certainly we are not reaching 100% completeness, so that our whole world is basically covered by such data sets. And this brings us also to the problem of actually supervised learning. Supervised learning basically works with manual annotations, and those manual annotations, as we have seen it in this data sets, in this great data sets, are coming with a lot of labor and time-intensive labeling work. So a lot of costs are included here, and let's say one image segmentation labeling costs 20 to 30 euro. Depending on the quality that you want to reach here. A bounding box costs 20 to 30 cents, also dependent on the quality that you get here. So this is a lot of money what needs to be spent here. Whenever you come to a new environment and you have new sensors on board your vehicle, so actually you need to label parts of the data actually again and again. So the domain shift is still quite difficult, right? And even if you go to other areas of the world, let's say you move to the Asian countries where you see traffic light in this, like in this two images here, the traffic gets quite complex, and you have never experienced that in Europe and US. So you basically can throw away your whole labeling nearly and need to get new data in this field completely. And also rare events are actually difficult to collect. So rare events, for example, would be a policeman on the street. So who of you have already seen a policeman on the street making gestures that you need to go that way or you need to go that way? Certainly not that many. And this is kind of an experience that you would say get 10 or 20 times in your life. So it's certainly not enough what is captured by this data set here, because those events are quite rare, and certainly not enough of them are there to really train your algorithm with that. The question is also, can we really annotate everything? Can we really annotate the latent states? Can we annotate basically what a person is thinking? And I also don't think that this is the case that we can really do that with our current methods. So we can for sure labeling kind of an abstract fashion of behavior or intention, but is this really the right thing that we are labeling there? So this is also kind of a tricky question. Actually, these relevant data structures are unknown a priori. So you don't know actually what to label and how to label it. And you can now apply clustering, density estimation, and anomaly detection to also find out what actually is coming in and what is included there. And this leads actually to the great topic of unsupervised learning. Unsupervised learning is machine learning without data annotations, and unsupervised learning tries to get the information without explicit labeling from your data. And this is actually great. And this is also why we are so extraordinary interested to get this on board in the intelligent vehicles domain, because if that works, and a lot of use cases have already shown that it works, this is a great enabler, and it's a really cost-efficient manner, because the unlabeled data is actually easy to collect, and if you don't need to label this data, then you're saving a lot of costs. And if you can then draw your correct information out of the data, let's say you are able to extract the latent states, the mind of persons, or the mind what's going on in a vehicle out of this data, would be actually quite nice. So in this workshop, we want to discuss actually those things. We want to focus on unsupervised learning with its variants, semi-supervised, self-supervised, and transfer learning, and so on. So, and also our keynotes will tackle a lot of those different variants and will nicely explain in what use cases you get already a benefit with applying unsupervised learning. This brings us to goal now. This brings us now to the goal of this workshop. So our intent is to explore the different machine learning techniques on unlabeled, partially or automatically labeled data with this workshop. We want to try to find basically similarities between different methods, between different approaches, and we want to encourage the intelligent vehicle researchers to learn about novel developments and challenges and solutions. Our keynote speakers are really at the forefront of the state-of-the-art research on unsupervised learning. So you will see a lot of different topics and a nice mix from academia and industry in our talks later. And this is also important for us, right? Because we think that there's still a great gap between academia and industry, where academia has developed a lot of great methods in a theoretical fashion and showcased it to some easy examples already. They have been not transferred yet to the industry, not transferred to the intelligent vehicle domain. And this is one important goal of the workshop, that we want to close this gap between industry and academia. So now you might ask why a separate workshop is necessary. And actually we are thinking those methods are basically important for a lot of different IV research fields, intelligent vehicle research fields. And we want to try to address those different views and those different challenges jointly in this workshop, and want to draw the conclusions also for different fields in the intelligent vehicles domains. So from that perspective, we want to try to be a proxy for the intelligent vehicle domain to basically get out most of the unsupervised learning techniques for intelligent vehicle research and intelligent vehicle applications. Now I would like to hand over to my colleague, Julian Kooij, who quickly presents last year's workshop and the speakers we had there before we actually start with the introduction of our speakers that we have today. Thank you so far, and Julian, now the stage is yours.
Yeah, so thanks, Fabian. So to give a quick history on this workshop, the history is not very long. We had one earlier edition last year at IV 2019 in Paris. So this was, of course, an on-site workshop. I think it was very nice because we also had very good invited talks. And we also, I should have mentioned here, had two nice paper contributions. Were presented there at the workshop. And so previous year we had Adrian Gaidon from Toyota Research Institute, Rob Weston from Oxford Robotics Institute, Antonio Lopez from the Universitat Autónoma de Barcelona, and Tuan Wu from Valeo. So that shows again the mix of industry and academia that we are looking for. And it was interesting to see sort of the varied topics. So for example, Tuan Wu talked about unsupervised domain adaptation, and Adrian showed at Toyota sort of the problems with scalability that they're running into and how they could use self-supervised techniques to improve depth estimation, while Rob Weston showed results using radar. So it's not just vision. And Antonio demonstrated different techniques in using simulators to provide more additional data. And the Carla simulator is a well-known instance of that. So these presentations were on site. We did not record them, but you can still look at our website from last year and look at the slides that the authors have made available. Fabian, if you could go to the next slide. So this brings us to this year's lineup. We have, again, 4 great talks. We have Serta Kanan from MIT, Salt Kira from Georgia Tech, Tudor Achim, who's CTO at Helm AI, and Anima Anantkumar, who is professor at Caltech, but also director of machine learning at NVIDIA. So you're all aware this is a fully online session this year. We have scheduled 45 minutes for each presentation, more or less including the questions. We'll ask in a moment, Sertak, how long he expects his presentation will take. We'll see how we can fit it all and how much time we'll have for the questions. I definitely encourage participants to ask questions after the presentation. It's not the same setup that we now have online. It's hard to ask questions, but I think it's really a nice thing to have a bit of interaction going on. You can ask questions via the chat and we can repeat it, or you can maybe raise your hand. We can also give you opportunity to ask your question yourself. We were recording these sessions. They will be made available on the info via conference system for participants of the IEEE IV symposium. And there's also a bit more information still available on our main website of this workshop at ULAD2020.com. So the talks, we have already here the titles. So maybe if we go to the next slide. The overview is that, well, we are using these first 15 minutes to receive people and introduce the workshop to you. But the layout is that we have a 15-minute break approximately in between. And that we have the 45 minutes to talk schedule where we start with Sertak, who's already here with us. I'm not sure if Sult, I think he will be joining us in a moment. And after the break, we will continue with Tudor Achim from Helm AI and Anima Anantkumar from NVIDIA. And in the end, we have scheduled some closing remarks to fill up the time we have here. Put down half an hour. I don't think we will really need to talk half an hour. We'll see how long it takes to maybe summarize some of the findings from this workshop. And of course, maybe see if we can draw some conclusions here. So everybody's invited to stay along for as long as you can. We realize that we are having here different people from all over the world. So maybe you will need to go to sleep or to work or do some travel. I don't know how you, if you can manage to be here along with us for the whole ride, but you're definitely invited to. So I think we are exactly on time, if I'm not mistaken, for Sertak. That means, Fabian, do you want to do the introduction?